All right, welcome everyone. Just going to prepare by posting that we're live. We'll get going in a couple of minutes. Right, that's live there. That's good. And let's just post in the Discord that we're live, and then we'll get going. Beautiful. All right, the chat's up. Hey, Sully the cat. How you doing, sir? Welcome, welcome. How you been? Not seen you for a while. Just get my chat windows up. Let's close that. Right, let's close that window. Ah, crap. There we go. Beautiful. Okay, I'm ready. How's everyone doing? Hope everyone's having a good Sunday. Hope everyone's having a wonderful Sunday. So today what we're going to be doing is, as the title says down below, we're getting bloom and exposure in. So past couple of streams, we've added in like sky and come on. We've added in like some custom sky render thing, and we've added in HDR support, and we've added in DCI-P3 support. So the main scene is rendered in DCI-P3, and then output to HDR monitors or squished down into sRGB for SDR content, standard content. So like an old classical screen that doesn't have a HDR support. So what we've got here is a bunch of triangles going from the most bluest blue to the reddest red to the greenest green. And we're going to make these emissive and make them bloom. So bloom basically, if you were just to make these very bright, what would happen is brightness would just be contained within these pixels. What we need is a post-processing effect to kind of simulate what happens in the eye or on like a camera, I guess, where effectively it's like the brightness bleeds out into the neighboring area, right? And that's what's known as bloom. So it basically makes bright stuff look bright, if we put it into English terms. Yeah, this is the plan for today. Then exposure, because you noticed if we make it more daytime, it gets too overexposed, and we cannot output the pixels to the display and see a difference because it's just insanely bright white. So what we need to do is be able to bring the exposure down such that when we're watching a bright scene, it's a bit like our eyes, where the scene is going to adjust to the light levels and bring the brightness down overall. So I think we'll do a manual exposure first, and then we'll do the histogram based auto exposure. This doesn't take too long to do. It's quite simple actually. So I'm hoping we can squeeze that all in today. That's the plan. So, but yeah, how's everyone's weekend doing? Right. Let's go. So, bloom, 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 bloom. So we already kind of implemented this one, physically based bloom, I think it was called. It's on Learn OpenGL. So it's one of those guest articles. Yeah. I'll drop the link in for you guys. Actually, I don't have the Twitch on here. Just search it. It's on the guest articles and physically based bloom. So effectively, you take the full screen image, you downsample it and do a, yeah, I think it's just a downsample. And then when you come back up, you're doing an upsample and a blur at the same time. So there's two sets of shaders, right? There's a downsample shader and an upsample. But when you downsample, you got to do this sort of special wide kernel. So it's not just a 2x2 downsample, it's an even wider kernel, such that it can get yeah, it's kind of interesting, right? But so this wide kernel, when it's going from this image to this one, it's getting the sort of high frequency data, right? Because it's very high resolution. It doesn't go very wide physically, right? Because it's just you can imagine it's something like it's a 6x6 kernel kind of. But then the more MIPS you go down, the more physical area it touches. So that's how you basically get a very bright light that's in one place affecting the whole image, because obviously when you downsample it far enough, if it will eventually get caught by a very wide kernel kind of thing. So yeah, this is basically what the code looks like. We've already got it written out in the previous project, so we're just going to be porting a lot of that over today, and then we'll be doing the exposure, which I haven't done yet. Yeah, that's the plan. So if we just go to, let's have a look at the old project. So the old project had graphics. Let's look at the shader file maybe, because the bloom is probably in there. And Visual Studio, fine. So we're looking for bloom, I guess. This is basically the shader. There's a bloom downsample, and we need a bloom upsample. Great. So we'll just make those two compute shaders, and then we'll just bring the code over, and then we'll see what it's like CPU side. So I guess we'll leave that open because we might need it. So code modules, shaders. Okay, so we want to copy a simple one. I think a simple one is scene shade. Get that copy. Now we're going to say graphics bloom downsample. And then we'll I guess we'll copy paste that again. Call it bloom upsample. Cool. So we'll start with downsample first, because that's the first one which happens. So in graphics shared, we're going to add a new Hey there, Saha12, how you doing? Welcome, welcome. So bloom downsample. So imagine we have I think we basically just have the sort of bloom image, maybe. We also need to do a copy to the first MIP as well. So that's another good point to bring up, is like in the old code, let's have a look at what we did. So clear the bloom texture, copy the first MIP over, yeah, then do the downsample, of course. Yep, that makes sense. So what did the I need the texture that we're sampling from? It needs to be a sample texture. All right, so there's a sample and a storage. That makes a lot of sense. Yeah, so we're going to be leveraging a texture sampling. Yeah, so we need to have the storage image that we're going to write to, so destination, and then the sample, then the textured sample from, if you will, right? So that'd be a texture. So write only, read only. Oh, it's always read only texture. Yep, it's just like. Then what we need is the sample MIP, I guess. Yeah, the MIP we're sampling from. And the source dims and destination dims, possibly. That'd be. I guess we'll call it source, right? And source MIP. Yeah, cool. So we'll fill that in CPU side soon. I guess we'll just do the upsample while we're here, so we don't have to come back into this file again. So upsample. So it'd be an upsample and blur, basically. So I'm sure that's a very similar thing. So here's some old code that I had. So it's a sample texture, a destination texture, and a sample MIP. And there's some filter radius. Right. So it's basically the same, but it looks like it's a floating point filter radius. All right. Lovely. So let's go to the Bloom downsample now. Take a look at the code. So we're just going to do a classical sort of like, work out the coordinate within the texture, I guess. No. Let's change that a bit. So, all right, let's grab this code here. Right, so it still does a Morton swizzle. Interesting. Right, let's convert this code over to GLSL. So it still does a Morton swizzle. And I guess our bloom is always going to be a power of 2. We don't have to worry about going out of bounds. We can just skip that if check. That's the idea. So we would like to just bring this one over. Then the source coordinate, since it's a downsample, is just a times 2. And then an add, isn't it? Okay. Then an add 1. Gotcha. Then the UV would be a cast into a vec2. Vec2 of the push constants source dims. I've got a macro for that, innit? Yeah, good. Now, it's just a divide. Lovely. TD, what does that even mean? Well, it seems like the inverse though, doesn't it? So it's like a... Yeah, so it's divided by... the inverse of the Yeah, sorry, it's divided by the source dims basically, so it's the inverse source dims. Now, I've got this sample macro just to make this code a lot more easier to read, and you're basically just offsetting based on this. So we need to find where I do a texture sample at a particular MIP level. I think I've got one in the code base. It's called texture LOD, isn't it? Yeah, one of these. So we basically want to put this here. So that's already a push constant. So push constant sample. I call it source. The source. Yeah, that's it. So I'm saying get the bindless texture for that. Yep. Then do sampler 2D to add a sampler to it, basically. Now the sampler should come from the globals, and I think yeah, be a clamp linear sampler. I think that's what it's called. Let's just double check. No. So sampler ID, I guess it's called. Yeah, that's it. Cool, cool, cool. Now, lovely. Then we have the UV. So the UV would be something like this, right? So it's like an add. So source UV, add this offset, and then there'll be this sort of MIP level as well, right? So that'd be very nice. So it's just basically source UV plus the vector 2 of this td.x, x off, I guess, yep. And then push constant source MIP level, yep. And that should replace this line here now. Lovely. So we're just sampling at these different offsets. And I think the blog post calls it like a tense filter, basically. If we just find it. Sampling. Yeah, so it's this one. This one was, the same algorithm that's using the Call of Duty Advanced Warfare, I think, that Sledgehammer Games did like a good while back. Hey, sudo, please. Are you related to the developer TempleOS? No. Why would I be related to him? So that would then be... And here we go. Multiply. Yeah, so we're getting a quarter of the S4 for some reason. Why S4? Oh yeah, the fifth sample, right. Then it's in like a multiply add and all this lot. Bananas. We should double check this is all right as well. Right, so it's just an accumulation basically, right? Yeah, add. And then multiply. Right, I don't know if this will make it better. But we put them, so they won't make dependencies on it, hopefully. I don't know. Files are probably smarter than that these days, but then it is a GPU, so it's probably different. A CPU, right. Yeah, so we color plus equals just accumulate the color. Right, max. Yeah, my logo says Hero Studios. Yeah, because it's for Jesus Christ, right? You know, are all Muslims related to each other? Are all Hindus related to each other? So max. Yeah, so I don't get perhaps these are in there, right? Let's give that a little. Let's compare it over to this code here. So effectively, they're doing this sort of ABCD, so the number of each their sample whiles is like done with S, right? Now -2 + 2 times a y, basically a y off. And if I put 0 in there, obviously it does nothing, right? Yeah. So it's like I see. So -2 + 2. Yeah. +0 +0 +2. Yep. -2 -2. Cool. Right, and then these are just sort of plastic. Yeah, so just ones and stuff like this. Cool. This is the sample pattern. Lovely. So I'll give us this lovely sample pattern. As we downsample, then we just combine the results. So it's just the fifth one down, which is E. And then we want like an eighth of that. Then you're accumulating your samples. F I H. Yep. Yep. K J. Cool. Yep, that's right. So those are the right numbers there as well. Lovely. And it's got a bit of max there, so it doesn't go down to absolute 0. Cool. We just store that back out. So we just got to make a store now. And we get to the upsample, which would be super nice. Lovely. So storing out, obviously, we'll just use the store which we had up above here. We're going to store on the destination image, and that would be at the DST coordinate at that color. Amazing. Lovely. Now, what's all this here though? Why is there like a preload thing? Oh, did I try and do some optimization? Where I tried to preload some of the samples and stuff like that. Yeah, so I was trying to see if I could reuse some of the samples by having a wider... Yeah, we won't do that. Too much extra work for now, I just want it to work. Optimization time will come later. So that's cool. Lovely. Look at that. There's our down sample. Let's write the up. No. So balloon down sample. Now let's go to the up sample. So in the up sample, kind of similar. This one will do a blur as well though. Let's drop this down here. Right, so we would like to take that line, put it here. We'll put the store at the bottom, and we'll get rid of all this code because we shouldn't need it anymore. Right, destination coordinate. Lovely. Do the swizzle so it's in Morton order, such that it will be more efficient. Then do a divide. Did I get all those divides right? Yeah, I did. Was there any divides in the above one? Hang on. Yeah, I did. Cool. That's good. Right, so back to, we want to access the push constants, get the source dims, then add 2.5. Yep. Yeah, we're going to add 0.5 to this one. That makes sense. And there's this sort of filter radius. And now we need to do the sample. So we're going to get this one here. So that will be source, clamp linear, add vec2 offset, and then source MIP. Lovely. Cool. Right, so plus radius, minus radius, all that good stuff. Apply weighted distribution using a 3x3 tenfill. Oh, right, this is the tenfill, so it's on the way back up. Right, that's sort of blurring. Right. Cool, so that's a multiply. By 4. So you're sort of adding them all together again. And then I multiply by that 2. You accumulate color. Okay, so hey, AK Dog, how you doing? Hey man, new here. Welcome, welcome. How did you get into game development? Did you study or just jump right in? Just jumped right in really. The schools around me weren't really offering it. I was just doing. I think I started doing stuff from from college really. They weren't really teaching much programming either. It was computer science, and it was the programming they taught was just horrible Java stuff. But yeah, it just jumps right in. I you know we live in a day and age where the school system needs a replacement because it's not really adapted for like the internet. You can learn so much now just online. Um, you know, access to resources is available everywhere, any country basically. You just need enough time and, the willingness to sit down and learn it. I wouldn't be worried about going to a particular school and having a particular tutor because that's all just, yeah, just not needed. But it's good to have people who you talk to. So joining like an online community where you can sort of like know some folks online who can help you through stuff and help you think through things and see where your thinking is going wrong, stuff like that. The only reason why school or that could be worth it is you get a piece of paper, and other human beings like piece of paper. Uh, basically, but even that's kind of questionable. You don't know how, what it will be like in the next 5, 10 years. Will piece of paper still be acceptable, right? Because at the end of the day, everyone goes to get piece of paper, then they don't really perform very well, and the piece of paper becomes worthless. And then it's just some sort of entry thing that everyone needs is piece of paper. All right, let's quickly double check. All right, so there's like any. Yeah, times equal. Burp. ECG. Yep. FG. Yep. A, B, C, D. Beautiful. And E, F, D. Cool. Nice. Lovely. So why is it doing a color equals add? What? Why is it doing a load? Oh, because they were blending it. There's a blend. It's a pixel. Theirs is a pixel shader. It's a blend. It's an additive blend. Isn't it? If you see it. Where's the additive blend? Oh. Restore if this was default. Yeah, blend. Yeah, additive blending. Exactly. So because additive blending, we basically just, well, additively blend. So we need to do a load. Great to hear. Thanks, man. I'm helping a friend who works on quite a big game with their new projects and doing music for it. Awesome. But really interested in getting into game design. Code spins my head at the moment, so it's just practice probably. Yeah, yeah. It just depends if you feel like yeah, you can always try it out. I remember when I was first trying to understand like a for loop, it was like the most hardest thing. Or like understanding a pointer as well was the most hardest thing. But really, when you actually get in there and understand it, it's the most simplest thing ever, right? And yeah, sometimes you just need that sort of explanation that just works with your current mental model. You just need to look around into some different places and have people explain them, and it's like, oh, that is the most simplest thing. I'm not sure why it took me so long to understand. But yeah, so it seems like you're interested in music and game design. That's cool. Yeah. Yeah. The thing that's great about games is that it's a very big area. So if you're into like doing multiple different things, uh, you can do that. Um, and especially if you work on some like smaller indie game, you will be doing multiple jobs. Now, obviously, the industry wants you to sort of like specialize and say, "Hey, I am a, extremely specialized artist or an extremely specialized programmer." But you know, uh, in real life, people are not really that. But then, God sort of forces you into those things, unfortunately. But yeah. Okay, so we just need to load. So you find a texture load. Scene shade. Let's just fetch one of these out. So that would have been here. So that would have been a load 2D from the destination texture. That's fun. Yeah, so it would have been RGBA 16F at DST. That's not write only then. So we need to go to graphics shed. Sorry. We actually want a read write. Thank you. Read write. I guess no read only then. Okay, cool. And then oh no, we'll rewrite both the times. Yep. Coordinate load. Oh, lovely. Then we store it in there. Jobs are good. And DST coord. Additive blend. Oh, look at that. Cool. So I think that's basically the two shaders written out. So now we just got to actually wire them in, get them compiling, then kick them off from the CPU side. So we'll pop into the build script for now. We're going to go to, let's find a reasonable place to stick it. Right, so I'm going to say bloom, upsample, downsample. Right, step one is that. So I guess we get them compiling first. All right, so we had some problems. Can I open file? Scene. Right, so I think I got the name wrong. So let's have a look for that quickly. Yeah, I didn't put the CS there for compute shader, so it got completely lost. And then we got the same thing here as well. Right, tons of errors, but don't worry, it's probably not that bad. 12. Okay, I've got to change that to a iVec2 and that to a vec2. These are all vec4s. Whoopsie. So effectively, I've my own little custom vector type, which is aligned to a scalar type, so a floating point, right? Just 4 bytes. But then the built-in vec4s are aligned to 16 bytes, right? So, well, they're nice. But it doesn't matter if you use them in when you're making local variables, because that is obviously going to be like the vector registers and stuff like that. But then when you're storing it in buffers, you want to use the scalar aligned one, so you don't end up padding the crap out of your structures and wasting memory, because you want stuff to fit into cache, and you rather pay the cost of of loading them unaligned. Cool. So we do want to go into downsample quick. Your presence is heaven. Let's go. Mm-hmm. Mm-hmm. Me. BMT, how you doing? Good to see you. Hope you're having a good weekend. Oh wow, the party in here now. My chat keeps disconnecting on my laptop. It's really annoying. What's happening? Also, what's the thing with the Vulkan logo in your quick start thing? Oh, you're talking about the oh yeah, that's the Vulkan configurator. All it is. So this thing allows you to configure. It just comes with the SDK, and it allows you to configure all the layers and stuff. So you can turn on validation basically for any executable that runs. The next time your Vulkan executable runs, you can you can toggle all of the settings without touching the stupid JSON file. And this does work on Linux as well, but it's more easier to see on Windows because obviously everything is like on Linux. You have to install it in a different package, but it is there. It's just called vkconfig in the terminal, and you can access it. Oh, Linux, I miss you. But yeah, you can do like to break on these debug actions and stuff. It's all really cool, and turn on extra warnings like threading stuff and or the GPU validation. That's another one. So yeah, GPU assisted validation, which is cool. Yeah, very nice. Hey, oh, this is Glass. How you doing, sir? Nah, because CPP is horrible, right? There's too much PP all over the place, and as you would know when you have a child, which will come soon in your life, the PP, yeah, it needs to go down the toilet, and I don't really want it all over my computer. So I'd rather have it just out of the way. So we just stick with C here. Yeah, I was using Linux. So basically, Wayland made me turn to Windows 11. So everyone's having the exodus to from Windows to Linux, and I'm having the exodus from Linux to Windows. It's just amazing. So for me, Windows 11 is the promised land. Yeah. No, all jokes aside, I do want to go back to Linux and use it. I've been using it for like over half my life now, but it came to a point of like RenderDoc not working, and I needed quality graphics programming, and it means I can just not support two operating systems and three different window APIs, which is a big help for now. So whilst I do all the graphics, I'm going to just be doing it on Windows. And if I can convince myself later on to go back to Linux, I might do that. But for now, Windows is the way, unfortunately. So yeah, I'm married, I have a son. I got to grow up sometime. C++ is close to yeah, exactly. It's yeah, the problem with C++ is this, right? All you need is structures and functions. But when you have more, you always will convince yourself this is the time to use templates. This is the time to use inheritance. This is the time to use closures or whatever it is. Then turns out later on down the line, you look back at it and go, hey, actually, that code is way more complicated than it needed to be. I didn't need those things. You know, it would have been so much better if I just did it this other way, which didn't use any C++ features. You know, and that's the way it always goes. So I would just prefer to not have the temptation, right? And that's what it's about. As a Christian, is you got to avoid putting yourself into needless temptation from the enemy. If the enemy's lingering around in all those C++ features, you just rebuke that at your life and move on. Because after all, Luke 10:19, this is the authority that Jesus gave us. You gotta get a proper translation. You know, God gave. Oh, hang on a minute. God gave us the authority to make, over the whole earth, right? Dominion, right? Jesus, when he came, he gave us dominion over the enemy. Because, we kept screwing it up and giving it to the devil. We say, devil, you run the world. You get us all into credit card debt. You get us all into, you get everyone watching Netflix and watching all soft porn. But yeah, Jesus gave us the authority. So I give you the authority to trample on serpents and scorpions, all power of the enemy, and nothing by any means shall hurt you. So what this means is whenever there's temptation everywhere, like in C++, we've been given the authority just to say no to the whole thing and just stick with C. Yeah. So just use the authority and come back to C. So just rebuke the enemy in your life wherever you see him. 12, number 12. What's this one complaining about? I need to put an underscore there, that's right. Okay, so that was complaining for what reason? Because I need to say GPU. Second argument must be a scalar sampler or a sampler shadow. Okay, well, that's because I didn't write the word sampler in the screaming snake case. Oh, it compiled for some reason, which it shouldn't have done. That's a bug in my build script. Oh, no, it's not. Okay. What about the downsampler? Is this one even compiling? It's not, is it? Beautiful. 15. Huh? Macro expansion. Yeah. Ash, where's the... Unexpected end of file. Oh, that's because it was reading a half-written file, maybe? Oh. Oh, okay. It unclosed. Thing up there. Damn it, GLSO. Life was so much better without you in many ways. Convert from const float to vector 4. Right, which one is float going to vector 4? Hang on a minute. Texture LOD, is this, what does this need? It's going to give me a bunch of template stuff in it. This source map is going to be a... No, it's just U32. Right, so the whole... there we go, the comma operator. Lovely. Alright, so we've got the shaders compiling now by the looks of it. Very nice. What my stupid thing? Oh, the Wi-Fi went on my laptop. This ain't good. Right. Why has it gone midstream? Piece of work. Sometimes it needs to reboot the whole router just to get it to work on the laptop again. Oh, it worked. Lovely. That's what I like. Right, see where I get the chat to refresh the page. Alright, it's back. No, I think it might be me still dropping frames. I have seen it gradually happen, but it's better than it was. I think, yeah, it happens sometimes. How's it going on Windows? Any significant discomforts compared to Linux? Not too many. It's, you know, the terminal's a bit different. You know, the compile times were obviously a bit faster on Linux. And no, I get to use Helix on Windows. It's fine. And I do get Red Debugger as well when I need to use one. So it's been quite a good experience actually, but yeah, I haven't got all the AI problems that people have been having in Windows 11. Maybe I haven't updated it. Just kept it on a specific version. I'm not sure what's going on. It's been quite alright. What else? Yeah, I think that's it so far. Yeah. Yeah, Windows does some things, you know, does things better. Also the desktop, yeah, I think some aspects of the Windows desktop is more stable, but then again, it's more clunkier, you know. So I guess with Linux, you sort of trade a bit of stable, like a bit of more, it's a bit of, more of a less stable desktop, but things are just snappier. But you don't really encounter too many bugs sometimes, but sometimes you do. Yeah. Right, so we're compiling. So here we go. So we get to go to graphics now. Graphics VK, I mean. Now we get to make a new function. Right, we'll like making new functions. I think I'll put it just before post process, maybe. Maybe it is kind of part of post processing, isn't it? Really. So perhaps we just throw it in here, right? So, or it could be separate. Yeah, let's make a new function. Call it bloom. So here's what I made earlier. So effectively, we want to do like a. Oh, okay. Oh, it's got a lovely push scope. I love me a push scope. Let's do that as well. So GPVK push or profile scope. So we'll call it bloom. So it shows up nice from the profiler. What's this complaining about? Let's see, no complaining. Oh, just took a while to compile. Anyway, so now this code here. So yeah, I have some settings in the old code. I need to really rework the settings again. When we've got enough features, and we can go back over that stuff and add it in. So the basic idea is round up to the nearest power of 2 such that no MIPS dimensions will be an odd number except the final MIP. If we have an oddly sized MIP, then the following MIP levels pixels will represent less area of the screen than it would have, since the border would be oddly sized. Since the border of the oddly sized MIP will be ignored, exactly. So we want to avoid those cases. So right. So the dimensions should be available in scene dim should be available in yep. That sort of global structure that we have for this module. Then we use our lovely calculate. I'm not sure if the final MIP is going to be odd because it says go up to an 8x8. So that's actually not really. Yep. So the lowest MIP will go to an 8x8 basically. It's calculating the number of MIPs that we need to get from the current resolution way down to this one. And then we allocate our texture. Now we want to make sure, let's make one of these. So we should probably call this the scene bloomed image or whatever. Lovely. Now, so all right, how are we going to allocate that? So it's temporary VK image temp alloc. Alloc, what's it called? Temp image alloc. So temporary source is basically when you're recording the command buffer, right? Or you can basically allocate and deallocate some image, and it has a lifetime up to a frame. And when you sort of deallocate it and try and allocate another texture, it will basically like try and alias the same memory again right within the frame. So it's really, great for keeping your VRAM down. Obviously, you just got to make sure you don't have any bugs because then you have problems. This abstraction also supports allocating and it supports deallocating and reallocating the same image ID, but it will point to a different descriptor in the descriptor set. So you have to, yeah. So it's really just a nice feature. You don't have to keep making different image image IDs, right? Or making new images, sort of thing anyway. Pretty cool. But you need the image spec here anyway, so cool. Right, so let's copy the scene shaded one. Put it in there. Now we do want to make sure. Oh no, it's cool. Yep. So is it a color attachment ever? No. Storage image, yes, because we read and write. And sample because we use a sampler. So then it's going to be that RGBA 16F. Number of MIP levels is bloom MIPS count, and the dims is going to be sort of bloom dims, so it's the rounded up power of 2. Then we simply just do something like this. Oh, we need to add a lovely special flag. So this is a new feature that I've added in, which allows it to automatically generate all the MIP views. So because in our, because shader programming is terrible, and you need to basically, where's the one? Yes, so whenever you want to write to an image, right? Notice here I'm just doing it, grabbing the descriptor from the descriptor set, and then oh, that's loading, sorry. Yeah, grabbing the descriptor from the descriptor set, and then I'm storing. Whenever you want to read or write from a storage image, maybe it's just writing actually from a storage image. You can only write to the base MIP level. So that means if you want to write to a lower MIP level, you have to create an image view and you have to juggle those around. This here just basically says create an image view for every single one of the MIP levels that you've got. So then we can just do a bit of, and it creates them sort of, it allocates a range of descriptors. So you can just do a base offset and grab the descriptor and give it to the GPU, or to even do the offset within the compute shader or the pixel shader or whatever you want to do. So it's just a little stupid workaround we have to do, unfortunately. But it's the way it is. I think I'll put the bloom dims in the... Oh, it's still there, it's good. Does that get pushed up into the globals? It does, doesn't it? So we'll put the bloom dims in there as well. Might be handy. So that's just globally accessible across the whole GPU. We'll find that out later on. So render bloom, we should just be able to say right. Upload globals. Yep. And then, oh, a number of MIPS as well. For some reason, we'll do that as well. Why did we need that? We should need that last one. Let's just stick this one in here though. Cool. So that's got all of the sort of U32, lovely. All the metadata, if you will. So let's go ahead and figure this one out. So this does a clear. So we've got another thing for this, slightly newer one. So graphics, image, clear. Oh, sorry, GPU, clear, image, this one. We haven't done this yet apparently. So what does it entail? Let's have a look. So image ID is going to be the bloom image. So it's this one here. What do we want to clear though? Well, that's a good point. What do we want to clear? Why are we clearing the whole thing? Because when you're doing the down sample, surely you're just setting... Surely you're setting every pixel anyway. Because down sample isn't going to do a... Downsample just does a store on every single pixel. So, right, so I think the reason why it wants to do the clear is because, yeah. So you want to clear the top MIP level because you're going to have border pixels. That's why. So clear the, clear MIP 0 due to uninitialized border pixels. Yep, that's why. So we're going to have number of MIP levels will grow as 1. Then the value is just going to be black, so I think we can leave it. Wait, do we want black? So, cool. So that will then be GPU VK clear image, I think it's called. Yep. Just pass in the clear like that and voila. Nice. Now the next one is we need to copy the scene. So it's a very similar one to the one above, GPU copy image. This one, so the destination would obviously be the bloom. GPU VK. The source is going to be the scene, the shaded scene. Now we can leave a lot of these parameters as 0. We want to copy though the full scene. And what else? I guess we could have left that alone. What's the sort of default that it does? So if component 0, then is the source, we just mip dims minus the source offset. Lovely. Yes, we just leave it alone. So we only want to copy though 0 will use all of the min. What does it mean by all of the? Zero will use the min. Yeah, so since our scene has no MIP levels, then it's just one MIP level. Be 1. Cool. So just copy the base MIP. Maybe I can make that explicit. That. Right, just copy the base MIP in to the bloom texture. Lovely. Now, this is where the fun begins. Downsample, then upsample, basically. So we're just going to copy that, give it a little bit of rework. So push constants, so it's graphics, bloom, downsample. You're not going to give me that? Graphics VK shared. That one. So source MIP to MIPS count -1. Destination MIP is source +1. Yup. So right, we find some of the new code base stuff. So it's something like this. So it's like destination is right only, and that'll be bloom texture. But it's plus this destination MIP such that it gets the image view that targets that specific MIP level, basically, in the descriptor set. Now that's going to be a bit funny, so we need to... Yes, I think afterwards we need to... It's typed, this is the problem. So we probably need to say instead pc.dst. whatever this is, because this is how I make it type safe, basically. Just by making a compile error if we can't set the right field inside some macros. Then the source is going to be... It's going to be one of those textures. Because it's like a sampler, isn't it? Be an F. Then the source MIP. Lovely. MIP dims. So access to calculate for me at some MIP level what the dimensions are. Right. Lovely. And then we just simply do a dispatch. Now I didn't put those shaders in the X macros, so we just go ahead and do that. Very simple. So it's called bloom, downsample, and bloom, upsample. Cool. This one's downsample. We're doing the classical 8x8 thread group thing. Nothing too special. So the final one would simply be upsample. Now, I'm going to copy all of this and we'll just basically refactor it for the upsample. We are copying and pasting, so it's prone to having some problems, but here we go anyway. Right, so still using destination. Yep, that's cool. So still doing this sort of source image stuff. Still doing this sort of source MIP stuff. Though, yeah, still doing this destination stuff actually. But this will be a read-write image instead. Okay. Then there's a filter radius. Don't forget the filter radius. So I think that's it. Lovely. What are you complaining about? Lowercase, please. Now this needs to come over this lovely constant. Just got to find it. Right, it's a number of 2 apparently. Min and max. Okay. So there's a bloom strength as well. I don't know where that fit in, to be honest. Alright, well. So we'll put that somewhere in like the shared header file, just somewhere at the top, like every other constant. So there we go. Put those in there for now. Take the strength out of the way because I've not seen it being used. And voila. So it's basically there now. We just got to bring it into the post-processing step and actually use it. Although we can actually just go ahead and test it out now and see it working. Oh, there's a filter radius. Crap. What do we do? So we, in the settings. So we do kind of want to find that file quick. Okay, I've got the file here, haven't I? So settings. There's a default value for it. Bloom strength 0.1. Filter radius 1, I guess it is. Oh. Did we not even use a bloom strength in the end? Oh, the bloom strength maybe got applied in the shader, the post-processing shader. Yeah, this needs to definitely be configurable. Right, so it's like a normalized value between 1. Okay, I see. So we basically want to make... Right. To do bloom radius same. So this would be a value between 0 and 1, so it's normalized, right? So it makes it easy to work with either 0% or 100%. And we have some kind of min and max within the engine. Yep, bloom strength is something that is passed into the post-processing shader, that's right. How much does it get applied on top of the scene render, something like that? That's what it is. Yeah, it's like a lerp between the scene and the bloom texture, that's right. Now remember. So we pop over in the texture viewer, or we could do that, or we could look at the profiler first, so let's have a look. So we'll just see here, there's a... Oh! We're not even running it just yet. So after the scene shading, we just want to do a render bloom, like so. And of course it doesn't want to work. What have we stumbled across here? Well, of course there's some problems. So I'm trying to use a texture in two ways. I'm trying to use it as a sample image and a sample image and a storage image at the same time, I think. So that is, and I'll get some validation error because it's probably in the wrong layout. So destination optimal is not compatible with sampled. Oh, okay. I need to stick on some image usage, I guess. No biggie. We'll do that. So and my computer's frozen. Right, I got a new one now. From destination optimal image layout when previous layout is shader read only. Cannot transition bloom image from when the previous one is. Oh, so this means I've got the image layout stuff. My tracking code is busted. Okay, so shader read only optimal. The destination transfer would have been one of these two, but it's saying no, it's in shader read only optimal. So that would have been because read only optimal would have been because of the texture 2D right here. Shader read only optimal. And then yeah, something like that. Let's take a look at the sync code. Oh boy. So we would have tried to access it once as a we could hop in the debugger here, but I think render bloom 497. Let's look at this just quickly. 49. Yeah, here, something like that. So we would have done a dispatch and then complained. Yeah, I think it's that problem I said earlier. So we're trying to use the same texture as a storage write only, but also a like a texture sampled one, a sampled image, which means it would have put the image layout in read only optimal and tried to stick it in the in the general mode for a storage image kind of thing. So it's kind of messed up the barrier code. So we could follow it down in the debugger, but let's just double check quick the code just to see if I could figure it out first. Right. So that state changes and stuff like this. Okay, so if it exists, it's going to try and merge the state basically. And then we've got this sort of after access mode, and it's going to merge the states, right? So it would come on. So we would be saying it's a a sampled and maybe just read write type of thing. So I think the issue is it's maybe in our conversion code. I can hop in the debugger just to make sure it actually does that first. Alright, so it's a new target. Oh crap. Right, so heroes engine bin game.exe. Maybe it's not bin. Build. So what? Alright, let's give that a play. What do we get? Yeah, so right in the validation error we expect, right? So this is what we want. Now we just got to find the here's our boy. So we want to put the line right, the breakpoint right there, such that sync image, beautiful. So we just keep going down. Now expect to get it into if it exists. This one right here. Yeah, good. So it's going to do a merge as I expect, right? So it's trying to merge access mode of 512 and 2. Brilliant. So now when it tries to do the sync code, oh, where's the barrier? I think it's in prepare. So yeah, we do a resource barrier. Then there'll be a conversion basically. How many? We've got 2 images, right? What's this image? The name is scene bloom image. I don't know what the other one is, but there's a conversion on the destination. Yeah, the image layout, new image layout, that's the one. So here, so if it's got copy, then I go there. If not, clear. Sampled. Right, so sampled comes in and takes priority. That is wrong. So sampled needs to probably go below compute, vertex, and fragment. No, because that means it's just going to always get that. I think we have to offer another mode now where we say, hey, this is storage, and that will go before sampled. And then you don't get the read only. Because I think shader read only is for... I think it's only for sample images. Sampled image, combined sample image, or an image, or an input attachment. Yeah. So, perfect. Right, so I'm glad that we found that problem. It's not too difficult to sort out. So, basically... Yeah, so whenever we do this sort of RO thing, it's kind of a bit wrong. It's easy to fix. So storage. Wait, is read write kind of already implying that? Yeah, I think read write's already kind of implying that. Yeah, read write, these are the storage ones. Maybe. True. No, it's not necessarily. If read... Yeah, no, I think it's already implying it. Let's go to image. Let's just go to VK image layout. Alright, so we can work some magic here. So what we're trying to say is yeah, so we want to say if you've got sampler set and you haven't got a mode of right of any read write, basically any reads or any writes. So I guess I can do one that's like bit. Just make that a bit more explicit. Like I'm basically saying if any bits are set. Maybe I can make that a bit. Cool. So that will fix our problem, hopefully, with the barriers there. Have a little look at that. Right, this seems like a bug that we had before, but I'm hoping this is in the up sample now. Maybe. So let's look at the line number 97. That's the same. How did we fix that before? So now it's put in general layout, which is what we want. Right, but it expected it to be in. Is that the second iteration now? Ah, well, we'll pop in the debugger. We'll run that again. Okay, so let's just run round. Okay, so it triggers the first time. Okay, we'll just look at that sync code. So prepare, sync, image, 2 images. The first one, before is 18, whatever that means. There's a clear. That makes sense. Yeah, then general. Then this other image is the same bloom image a second time. Ah, so it's trying to do the same image twice. Interesting. Why are we adding 2? Yes, it seems like it's adding it a second time. It says it exists. If the state has stage changed, yes. Push on another image to sync. Right, this is a problem. Okay. Right, shouldn't be too bad to fix. So before the dispatch, we do some syncs. Sync on an image. So what we're trying to say is if the state has if the stage has changed. So why does this matter? If you have one dispatch which happens and yes, if you have 2 different dispatches and you sync on, or maybe maybe one's a dispatch and the next one's a clear. You want it to put a barrier in because there's been a stage change. Something like that. I think this is what this code is trying to solve. But it's got a problem now where if you're within the same... Oh, it tries to... There's a stage train... Ah, I see. I see. Right, here's where the bug is. So, before we used the bloom... Oh, I didn't do the copy. I just wrote a structure here. No biggie. Right. So here's where the problem is. So before we do a dispatch, we do a copy or a clear, right? So those would be in this sort of like transfer um, stage in Vulkan. And what we do is dispatch, this is the compute shader stage. So we so because I synchronize on this Bloom image once here, it's saying, was the stage before different from what this stage is going to be now? So like a compute shader or something. And it says yes. So it appends this Bloom image to be synced. Then it tries it a second time and the same thing happens. It checks what the stage was before, it's transfer, different from compute. So it's going to push the image on again. So what we need to do is basically say it needs to be looking like at a different variable or something like that. Or it needs to already mutate that variable where it's looking at. So before access mode, after access mode. So I think if the after access mode has been set, then we don't want to. So we want to say if sync state after access mode is equal to none, and this, then we want to allow this stage change thing to take effect. What I think it needs to be. So get set to none whenever you finalize a command. The dispatch, when you do a finalize, it's going to go over all the sync states and set after access to none. Right, cool. And every time, but yeah, try and modify it here anyway. Cool. That's good. So that should fix those bugs. We should see. So seeing as these usage flags and it needs to have the usage flag for transfer. Very easy one to solve. Man, I was hoping to get to exposures today. There still might be time. Be a tight squeeze, but we can do it. Come on, what's this complaining about? Is this not compatible again? Right. Is on the scene shaded image. I've got the wrong one. Scene shaded image. Destination source. Here we go. Come on. Oh, that's looking promising. So, texture viewer. Wow, can you see that bloom? Can you see that bloom? Right, so here's all the history. You can see all the samples now. There's a lot of them, yeah? Now, as we... Right, so let's see in action. So we're on clear image. Then we copy the image in there. Then we down sample. So that would have put it into this one here, right? So previous frame that would have been. Anyway, yeah, so down samples, down a full MIP chain. I think it's reusing the same memory, so it's sort of texture is not very nice. I guess I could have cleared the whole thing to make it anyway, but the basic idea is we need to do this one. Boom. So here's the sort of bloomed result. It's a bit blurry, right? It should look blurry. That's the whole point of it. There it is. Well, so the white level is actually quite high because it's HDR. So if I break it down to closer to 1, you see it here. It's very overexposed. Right. So now you're supposed to sort of bring that blend this in, right? You're not supposed to accept the whole thing into the scene. You're supposed to sort of just blend a portion of that in. So that's where the sort of bloom strength comes in. So that would be, so let's go to post-processing. I just got to try and find the old one. Yeah, so post-process, there's like a lerp basically based on the bloom strength. So if we have a bloom texture, load from the scene. If we have the bloom texture, because maybe, yeah, maybe we turn it off as part of a feature. Yeah. Then sample lerp for this. That would then be, okay, so scene, so if PC bloom image, so push constants, right? We'll get this sort of bloom color. Then we'll simply say color equal lerp color bloom, and then some kind of bloom strength, which we'll pass up. So we need to hop into the post-process, shared post-process. Okay, so we just pop into, okay, yep. So post-process, now bloom strength equals, so to do, right, bloom strength setting. We have a settings thing, but I've just not bothered doing it just yet, so we'll just pop it in here. To do bloom strength setting. So I think we wanted to put it at 0.04, and that's the amount we're going to accept. Very, very small. I think that's what we used as default. Let's see if we can get the settings up. .1. Right, so it wasn't that low. Lovely. So let's see how that goes. Right, so I don't know if... Yeah, we can see if it works or not quite easily. Go to post-process, yeah. Just comment out that line. Right, I can't really see a difference. But, oh, we didn't pass in the bloom image, that's why. So of course it's not going to work. Right, let's compile that. Here we go. Right, I need to go back into post-process again. So this needs to be like a Boolean expression. Apparently an integer is not enough. Oh, there we go. We can clearly see that taking effect. It's definitely looking quite a lot brighter now. Now I just need to get it. So we comment that out. There we go. See, yeah. So there's the bloom shader happening. So the sky is just blooming, but we want to make sure the triangles bloom. Right, that's what we want. So we'll mess around with the sky for a minute. Turn the sky off and make the triangles emissive. We're done. What Christian-based video games videos? Well, what are they? The Christian-based would just be basically, either either tell a Christian story or a Christian based something in a Christian based worldview, basically. You know, something that will point people to the faith, right, rather than away. And it just depends really on sort of yeah. But most likely, Christian based content for so like Christian games, Christian videos maybe, and it just means basically like so the basic idea, right, is you could do like the most important message is like the gospel, right? But then that is kind of done a lot. So I don't know whether or not it is wise to do that. Just needs lots of prayer and stuff. But probably. But I'm liking the idea of doing something where it's a bit more towards the um towards the sort of like to the Christian who's sort of because lots of Christian stuff kind of is quite it doesn't tend to go too deep, right? So maybe a sort of a deeper piece of Christian content, if you will, maybe something more spiritual or but yeah, not quite sure yet. It just needs lots of prayer basically. But that's what it means. Let's turn off the sky. Oh, turn off the sky. The sky's done in scene shading. So it's this one here. So we do that, we shouldn't have any more sky. But then it's why didn't that work? There we go. Wow, I can actually see them already blooming. You guys can already see that, I think. That's just my monitor. Yeah, they're already blooming, you can tell. Nice. So we can, sweet. Look at that. So we can have a bit of fun and just multiply. So if we take the instance color here, we just multiply that a little bit more. Let's just multiply it by 2. Even more bloom. So you notice the blue is the darkest. All the bloom. But yeah, this is where it starts to sort of get a bit white now. Amazing. Amazing. Cool. So that's the bloom working there. I'm happy with that. Well, it does look a bit alien. I'm seeing kind of the pixel pattern here. We might. Are we better off doing a sample? Yeah, we're better off doing a sample. What is the There's doing bonus stuff like lens dirt and that. We're not interested in that. So yeah, I wonder. Yeah, so the bloom final. Is that what we're looking for? No, 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 no. Where's the shader that writes out the does the blend like a lab? Blending. Right, we see this in order. That might help out. Yeah, so now render the fixed point color buffer quad. Yeah, so we're looking for this shader here basically. Shader bloom final use. That don't look good. Program choice 1, 2, or 3. Where? Oh, there's like an exposure thing in that. So, shader bloom final. Can we click on that one? Yeah. Cool. Right, so the new bloom does the scene. Yep, and then alert, yeah? That's what we do. But it's doing texture, which means it's a texture sample. Right? Bloom blur, well, we've got to know what that is. So bloom blur, we've got to find out what the sampler is, but I think they're using a linear sampler. So bloom blur 1, right? So what is that? So I'll find out what texture's been bound. So where's the slot 1? Active texture 1. Okay, so this bloom texture, right? What's that? Okay, so it makes the MIP chain. I guess it's just a. Where's the init function? Bloom MIP. What are you? Texture uint. Here we go. Yeah, so it is doing a linear filter. There we go. So we probably want to do linear filtering, and you see this sort of aliasing we're getting. It's a bit horrible. So if we switch it out for a filter, that might look better. So how do we do that? Well, I've actually got to swap it. Fortunately, got to go into shared. We're going to use texture 2D instead. And then cool. So in post, using that instead. like so. And then in post processing. What's going on? I pressed that. I pressed P instead of F, right? That's what was going on. So bloom image upsample was using the sampler. That's what we want. Now we're going to sample from LOD0. So we're sampling from bloom image. Clamp linear. Now we want to work out the UV. The UV would be, so it'd be U chord divided by vector 2 of G bloom image. Something like that, right? That'll be a linear sample now, and that should look a bit better. See how that goes. That would then... Alright, so what's this complaining about now? Wait. It's not a bloom image, bloom dims. Let's try that on it. 362 semicolon. Oh yeah. Right. That looks still seeing the aliasing though. So if we see our post-process image, this is what it looks like, yeah. So you can see it. Maybe it's because it's too powerful. Or the bloom strength is too much, maybe. Here's the bloom image. Let's go to the final click. And if we see it here, it could be to do with those filter parameters, the image itself looks a bit tiley, you know. Maybe that's the problem. Maybe that's the problem, isn't it? If we go down the... Yeah, I think it's probably integrating a bit too strong, maybe. My Wi-Fi died. Yeah. So I think it's not maybe we'll keep the sample because that's what it seems to. Is it really a good idea? No, let's undo the sample. I don't think we need it. I do not think we need the sample. Now the question is about probably the filter radius thing. Probably that. So Right, so that's on like a 0.005. So maybe that could be. Yeah, I kind of did it based on the. That's the full radius. Okay, so contextual space. Yeah, so maybe mine's trying to grow with it, which is probably wrong. Yeah. That's the problem. That's not good. So Minimax Y2. Let's see. Right, so their one is extremely small of 0.005. Huh. Mine is like way too big. I don't know, maybe we say to 0.01 maybe? I don't know. There we go. Anyway, we'll bloom radius. Do something like that. I think that's why mine's got loads of like blocky pixels. Give that a go. No, it's looking. I see a lot more blockiness, but maybe that's just because how. No, I'm seeing blockiness. That's right, but it's also very intense. So the intensity is probably not helping here. What do they pass in as the? Oh, where's my chat not? Bloom strength 0.04. Yeah. So yeah, mine is like really powerful as well. So let's go to our bloom strength in post. Oh come on. Right, it's looking better. Like I'm still seeing these blocky pixel here though. It doesn't look good. Not gonna lie. So we're seeing blockiness. Is the let's go to the post-processed image. Oh, finally, it's no. Ah, the chat's gone. Sorry, guys, gotta get the chat open on my phone. Terrible. Hey, Final Spawn, how you doing, sir? Welcome, welcome. Welcome, welcome. Rightio. We're back. Cool, cool, cool. Yeah, so that is looking way better, right? I'm not seeing so much of a blockiness. We're seeing like a smoothness of this now, but there is still some kind of blocky artifacts that we see. Now, maybe that's just because we need to tone the bloom strength down even more. I don't know though. So we look at the bloom. My face. Yeah, so these lower ones, these lower MIPS, they're really coming for a lot, you know. I thought that weren't really a problem. Why would it come out like that? That's the thing, isn't it? Let's debug. Yeah, so we've reduced the radius now. That's made a big difference. We have reduced... Oh, plus 0 times a diff. So 0... Yeah, exactly. So... I think it's something to do with the upsample, but this code is the same. The other one was, it's in UV space, isn't it? Oh yeah, it's in UV space, isn't it? Rather than texture space. So, what does that mean? Yes, this is in UV space as well, isn't it? Okay. Yeah, so our code is the same. So A, B, C, D, E, F, G, H, I. A, B, C, D, E, F, G. Yeah, cool. So accumulate, that accumulate, divide equal that. Yep. Then an additive blend. This is what might be wrong. Maybe it's right. Double check it. So their code is additive blend. So that'll be add. So it's, yeah, so it's one times. Yeah, so I think it's just, that's right, isn't it? Yes. Okay, what else could be the issue? Maybe we just turn the radius down a bit more. I think that might help. Although my source UV is offset by 0.5. Is that what we want? Yes, it is. Yeah, in the middle of the pixel, because it's in the pixel shader. We're just doing it in compute, it's just a bit different. Okay. Okay. So let's try and mess around with the filter radius just one more time, just bring it down a bit more, I think. So let's bring it down to half of that maybe. Maybe that will reduce the blockiness even more. No, it's really bad. Still see it. Then I got hot reload so we can... Right, can we up it a bit more? Not sure if I'm seeing a difference, to be honest. Oh. Look at that. Interesting effect. But yeah, that's interesting. You can tell that's way too wide. Okay, the build script's not really liking me changing it. Yes, I think there's a... It's really got to be based on the base resolutions at some point, I think. So that's what we need probably to figure out. Yeah, so this is a very... Yeah, very vital. So if it's too small, I think it gets blocky. If it's too big, we start seeing repeated patterns. Something like that, I can imagine. Right, I'm starting to see the blockiness again now that we used to have. The small blockiness, and then I guess you start to see repeatedness, yeah. I think... Oh, interesting. Yeah. Okay. Anyway, it's stuff to play around with. I think... what should we do? It would be a linear, isn't it? Yes, clamp linear. Good. Linear. I think the upsample would be the one with the problem. Remember to add bilinear minification filter for this texture. Ooh, this could be the issue. Edge clamp for this texture. Yeah, but we've rounded up to power 2, haven't we? Right, so maybe those are two problems. Maybe we shouldn't round up to the power of 2 and put a clamp. Yeah, maybe those are the problems. Don't round up to power of 2. Do the clamping. So add bilinear minification. Yeah, but I think we're already doing that, aren't we? So that'll be GPU VK. So clamp linear, right, would be clamp to edge. Where's the minification thing? Minification filter. So when they set up their bloom textures, there's like a parameter, isn't it called? Yeah, text parameter. Min filter linear, mag filter linear. Yeah, that's what we do, isn't it? Yeah, exactly. So that's fine. Clamp linear, exactly. That's what we want. Yup. Okay, yeah. So I think we're doing this fine. The edge clamp should something we should maybe do, but it's not the source of our problems. Yeah. Okay, I guess we'll just tweak this some later date. Right. So we should probably jam in exposure just so we can sort out the sky. And so we go back to the scene shade. Put the sky back on. And we could probably turn the camera back. To face direction of the sky. Yeah. And then we could probably turn back on the... Yeah, let's just leave it like that for now, I think. And yeah, then we can put some exposure in to start tweaking this. Because we see the... Where is it? The... Interesting. Alright, that's fine. Yeah, so we see the post-process. Maybe it's supposed to look something like this when we have it, the exposure be adjusted, right? This is what we're going to try and get, basically. Like that. Right, I'm just going to take a quick 2-minute break, and then I'll be back. No vibe coding. We're looking for in the current times. Hey, Xdas, welcome. Yeah, well, you know, I do use AI just to do some quick research and um, get some code which would otherwise be, you know, I basically use AI to do a good Google search because Google search has got terrible over the past like so many years. It just keeps getting worse and worse and worse. So we're probably going to use it just to get to the exposure stuff, but it is worth checking that it does make sense, the maths and stuff like that. But yeah, that's all we use it for, is just for a quick Google search. All right, I'll be back in like Right, welcome back. So, exposure. So let's just see what we. So effectively, it's just scaling down the luminance values right in the post processing. We just want to see like GSL game engine or renderer, exposure, manual exposure post processing, I guess. Please ask nicely, because at the end of the day, when the book of no, since the Antichrist comes on the scene, these guys are gonna be hunting you down. But to be honest, they'll hunt you down because you haven't got the mark of the beast. So yeah, maybe not. Maybe asking nicely doesn't matter. Anyway, oh, Revelation 13. Give it a read. So does this look right? It looks a little bit HDR color, manual exposure mapping, negative. This looks a bit wrong. So what about with a sort of histogram based? Let's see if it does it properly. They'd be doing it with EV100, right? And then, yes, you do your histogram. You basically sample the scene, right? Put it into a histogram. Pick. I think you pick the middle of the histogram. I'm not quite sure. I need to remember this a bit more. And then you base. So instead of doing an average of the whole luminance over the whole image, you can do a histogram based approach. So it avoids spiky values basically. You might have a very, very bright pixel and that will completely throw off your exposure, I think, something like that. And it also solves the problem. You can do like a weighted version based around the center of the screen and stuff like this. And so, yeah, I had one on my phone earlier which looked correct because I remember it before. Let's see if I've got the chat on my phone a bit. Yeah, so mm, 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 based. Oh, that was maybe with the physical camera stuff, but we probably don't want to do that. So, right, calculate exposure in the compute shader. Once you have a target luminance, calculate the final exposure, apply it as shown in previous step. Exposure equals middle gray. Isn't middle gray like 0.18 in divided by average luminance? Smoothing, use lerp. No. You want to do an accumulate based on delta time, right? Some gradually move over to it. Right. How fast was that bloom shader actually? We didn't even check it in the performance. There it is. 0.4 ms overall. Okay. Alright, let's check the chat. So I guess we can build the histogram. So would luminance, yeah, would luminance be different for a sort of P3 HDR input texture, I guess? Because you're in a different color space, those luminance values will be different, right? Yeah, that is true, isn't it? But then again, there's different types of weights even for a SDR. So that's my GPU shared. Luminance I've got. Let's have a quick little look. The ones it was using for Rec 709. Yeah, it was the ones that I had before. Yeah. So this, we probably, I guess we can call it like Rec 709. Right. But then we want we would like one for P3 basically. So those would be slightly different. So it's 2290, 6917. Cool. That'd be nice. Right. So let's start building the histogram then. I'm not sure how many buckets you need. Is 256 buckets a lot? Then it goes over all the buckets. So grab the color, get the luminance. Right. I'm gonna get the log of the luminance because effectively a linear scaling of luminance isn't like doesn't feel right. Right, if you square root it or whatever, or if you take the log of it, it looks more linear. Like it looks more linear perceptually. So it adds this such that it does avoids the non-zero value, I guess. Adds 10. Why divide by 12 though? Then see which bucket it falls into, basically. Right. And then the other way around is figure out which bucket has the most values that fall into it, the most pixels that fall into that bucket. And then discard the dark ones and discard the bright ones. Yeah, discard the bright bucket. Way of saying it, lower. Yes, that, you know, you skip a certain number of bins basically, so you just avoid that loop. Accumulate the luminance, the bin frequency, histogram divided by the total number of pixels which are in that bucket. Get luminance for the bin, basically do the inverse of that. And then why do you need to do all of this weighting stuff? My question. So you just need to pick a bin? Because the bin itself tells you the luminance. So when you're saying bin frequency, times the luminance, right? Is it just used to discard the bright and the dark ones then? Maybe it is. Then it's finding the average of the total luminance, and that's what you use for the exposure value. Right. Yeah, this could be done a lot better. Though, okay. Histogram-based exposure is more robust than simple average because it ignores the the outlier bright parts, such as small bright bulbs. Yep. Okay. You probably as well want yeah. I'm not sure why there is a divide by 12. Though what that conversion is. Why is there a plus 10 and divide 12 in the histogram? To remap the massive range of HDL values into a normalized range. The offset of 10 log to a small number is negative, right? So you want to sort of offset. If your minimum readable luminance is, then it's minus 10. Adding 10, shift the range. I see, starts at 0. Cool. Then divide by 12 defines the stops. The dynamic range of your histogram can see. If you shift by 10, you divide by 12, capturing 12 stops of light. Your maximum detectable luminance becomes okay. I see. If you have extremely bright highlights like a sun, divide by 20 to ensure values don't all clump into the very last histogram bin. Interesting. I see. Yeah, those do need to be tweakable, really. Some degree. Alright, let's just get it to get the other code as well. Yeah, that makes a lot of sense. That makes a lot of sense. So I guess we'll just yeah, I wonder. Yeah, you know what? I think we'll save this for next time because it would be a bit much to do. Because what we want to do, right, is we want to do that histogram based approach. We probably want to have a way to see the histograms, right? So we want to make some debug views. So we'll have like the bins which pop up down here or something like that. We want to see that the how many pixels fall into that bin, and then we want to we want to also probably only capture a sort of we want to probably ignore corners, right? So we want to have like a a sample area of where we actually care about. It's a bit like your eye, right? When you're focusing on and looking directly at a bright light, your eye is going to adjust quicker. Whereas if it's just in the corner of your eye and it's not really filling the whole room, it's not really going to affect how quickly your eyes adjust to that bright light. So we probably want to have like where the camera is actually looking to be more effective, right? And to go more into the histogram probably. Yeah. So that's something we'll do for next time. Awesome. So I'll write that one up. And I'll post that in the Discord channel. But yeah, feel free to pop by the Discord channel anytime and have a chat. We'll next be on Tuesday at 7:30 p.m. GMT and on Thursday as well. There's a stream on Friday as well. If you just check under the stream on Twitch, you'll find it all there. What else? I guess has anyone got any questions before we pack up? But at least got the blue mostly working today. It has got some slight problems with the pixel. It looks quite there's some artifacts with it. It can look quite blocky, but it does kind of look okay when we've got the sun. But in a dark scene, actually, it didn't look too great, did it? So I guess maybe if the scene is light, it should probably... Hey, why aren't I seeing no... It looks very bloomy on my display here right now, but not so much here. Anyway. Cool. Anyways. No worries. Yeah. But yeah, we kind of got bloom working too, it's cool. Moving on to exposure tomorrow. But yeah, good to see you, VMT. Oh, by the way, someone drops this in the chat last stream. It's a very good PDF on PBR. Go and check it out. I'm gonna post it on the Discord. It's pretty great. But anyways, have a good evening, guys. I'll see you all in a future one, and thank you for stopping by. Catch you later. Bye bye.